Hi, welcome to Code and Play. In the last video, I explained to you what is a class and what is an object. Today, we are going to see how to write programs using this class and object scenario. First of all, in the world of software development, building an app, a website, or especially a game can be really tough and not tough at the same point. What I'm trying to say here is you can make a game. It is really easy and also not that easy. So hear me out. First of all, for new programmers, basically learning programming is kind of hard. You can argue that it is based on the ability to learn programming, reasoning, logic, all that. But learning programming as a new programmer is kind of hard. And added on top of that, we have frameworks, we have libraries, we have plugins, we have softwares for porting, and we have a lot of things to learn. When you are working in this industry as a programmer, designer, tester, in any shape or form, if you are working in this industry, either you are in the game development industry or app development industry, you know that most of the times or sometimes people don't get the time they have or they want to develop an application. You have seen many games where the developers complain that they don't get enough time to develop the game properly. And yeah, it is same in app development as well, where the client does not give us enough time to build the application according to their requirement. So we need to write the programs as quick as possible and as simply as possible. So we generally follow the rule that if it works, it works. You might have heard that, and this is true because most of the times you will be working on a tight schedule. What if you refuse to work? Well, that is where AI takes your job and you lose your job forever. So either you do it quick or you lose it to the AI. So what is the alternative? Well, the alternative is not that easy and also not that hard. Let me explain. So back in 2000s, when the Silicon Valley was newly established in the California district, people from all over the world came to this Silicon Valley to develop, to form teams, to develop, to work on applications and softwares that we use today. The softwares, operating systems, everything that we are using today has been like under constant development since 2000s, early 2000s. Even the iPhone that we are using today is like, when was it launched? 2005, I think. Back in 2005 it was launched, I think. uh, I might be wrong, 2005 or 2007, around that time. iPhone was launched around that time. We also have Windows that was launched in 2000, around 2000s, right? So there are a lot of softwares that were launched in that era. Back in Silicon Valley, the concept was similar to what we are facing today. The thing is, back then there are so many programmers who were coming up with exciting ideas, new softwares, and everyone wants a piece of the pie. You know, the first person to crack the market will get the majority of the shares. As you can say, in most of the programming languages that we are using today, Java, Python, and C sharp. C sharp, it came late, and it also is a not a open source software. It's a proprietary software, so it is now limited to certain applications. Whereas Java and Python, they were under competition since the inception of them. So as we know that the like competitiveness creates a very big thing, the messy spaghetti code. Let me explain. So here, back then in 2000s, in the early 2000s, we used to have structural programming. Structural programming, basically, it means you are following some keywords, you're using some keywords, and you are using logics like functions, structures, memory allocations, dynamic memory allocations, so on, files, pointers, and so to create programs and apps. Back then, this was the norm. Then the era was like so competitive that people started writing applications so fast that their program has a probability to work. What do I mean by this? I mean the program might be able to work properly or might be crashing the application completely. So 50% of the times the program will work and 50% of the times the program will crash. There will be bugs, there will be messy programs. The programs, the codes that they wrote back then was like spaghetti code. It was not that not like every program is not that bad, but most of them are bad. So in the early 2010s, a like in the early 2000s and 2010s, a common ground was established that structural programming is good, but to write applications in a, like you can say, in a competitive environment, we need a structure, a proper structure. This is what called modularity. When you want to create an application, you need a proper structure for the application. Basically, modularity. What is modularity? You develop an application by creating modules. Let me explain. When you are creating a game, let's say a game has many modules like world, player, bag, uh, NPCs, dialogues. There are many modules like this, right? Each and every module is one single, you can say one single class. Okay. The world application, the world class will have all the world maps, the objects on the world maps and everything. The player class will hold all the player logics, the taking damage, equipment, etc., stats and everything. The bag will have all the bag slots, like dropping, picking up mechanics, and so and so. As you can understand, this is called modularity. When you break up the application in multiple modules, you can easily create an application. I mean, not that easy, but I'm just saying that you can at least have an idea what you're working on. In this kind of modular concepts, the most important thing that we are doing here is creating classes. In the previous example, I told you how to create a class. Class basically is the basic structure of the object. Whatever object you are creating, the class will bear the entire structure of the object. For example, here the object is a bus. The bus class, so the bus class will have the required data members and member functions. Understand? This is called as the object structure, the structure of the object. What object you are creating is, the class contains the object structure of the object, and the structure of the object is based on the object itself. Here, modularity is that it is explaining what object you are working on and the class that has the code. The class, for example, player, is based on player object. So in your game, whatever the player has, everything will be given in that class. In the game, if you have a world map, NPC, mini map and all that, interactions, monsters and all that, those will be in the world class. In the program, if you have a magic spells like spellbook, this spellbook class will have all the magic spells. So this kind of modularity is helpful to create applications, to create games. If you want to create games like this, Then you need to learn OOPS concepts. This was introduced back in 1985. OOPS concepts actually was introduced in C++ in 1985. Okay, the concept of this entire OOPS concepts is the reason for this OOPS concepts is to create applications using modules. Now, why is this modularity so important? As I said, it is easy to write. Also, it is easy to read. For example, if you want to create something like a game, you are using this. If you want to create something like an app, let's say e-commerce app. E-commerce app also has modules. So we have a payment gateway class. We have a items class where you show all the items, display all the items. We have a DB class which has the database object where the database will be like imported and exported. We also have a cart object, cart class, where you store all the data, like what type of objects you want to store, like what type of items you want to buy, those will be in the cart. So this is called as e-commerce. E-commerce, in the e-commerce application, the modules will be like this: payments, items, DB, cart, etc. In the games, you have world, player, bag, NPC, etc. So by creating these modules, you are actually creating a structure, a well-defined structure for your application. So anybody who is reading your application will know what you are working with. For example, if you are working on world, they know that everything in the class is related to the world concept, the code world. Or if you're working on a bag, everything in the class is based on the bag inventory slots. If you're working on spell books, everything in the class is based on the magic spells. So this is easy to read and easy to write as well. For example, if you have seen the series Code Venture, just a minute. If you have seen the series Code Venture, you might have seen this one. So in this series, I have explained some things like swing functions and all that. So let me show you what I did here. So in this case, if I click bag, I have inventory slot and I have inventory. So if I click inventory, I can see a lot of program is given here, right? There are some add items, there are some show inventory get items. So both of these functions are related to inventory. It is not related to player or world. It is only linked to inventory. So those who are watching this class, they know what they are looking at. If you're going into, let's say, world tiles, right? If I go to world, there is a code here that is showing everything about the world that I am working on. So these are the ends, x-axis, y-axis, and this is the place where I am drawing the world, right? Everything is in modules. This is the program is based on world object. If you go into camera, the entire class is based on camera object. Like this, we are writing everything in modules. This is why it is easy to read. So modularity, the program modularity or modular programming is easy to write and easy to read, as well as it is mostly like you can reuse these concepts into other applications. For example, if you want to write the same thing that we have here into another game, you can just basically copy and paste, or you can also extend this class directly. So this is the advantage of using modular programming. It is easy, it is fast, it is structured. Okay, this concept was introduced in OOPS concepts. The modularity was introduced in OOPS concepts back in 1985. Actually, this OOPS concepts was in talks since 1970s. Since the programming of C language was created, C language programmers were working on something to create a modular programming, but they were not successful. and OOPS concepts was launched in 1985 in C++. Well, back in C++, C++ was not actually a language made for OOPS concepts. It was actually a structural programming concept using streams, IO streams. Then in the later expansions, they introduced OOPS concepts. But Java, on the other hand, completely is designed with OOPS concepts in mind. So when Java came in 1992, this was completely in the concept of OOPS. It is using the concepts of modularity, the programming term called modular programming. Okay, this modular programming or this modularity gives us 4 different concepts. What are OOPS concepts? Basically, OOPS concepts stands for object oriented programming structure. So the structure of the program is based on the object that you are writing for. The programming is based on that object. This is why object oriented means you are writing everything based on the object. Now when you are writing everything based on an object, a real world object, the programming must be given in a structural format. The structure here is modular structure or modularity. Okay, so to implement this structure, to implement these concepts, we have 4 different structures, or we can say 4 different concepts. The OOPS concepts are these. So in OOPS there are 4 concepts. What are the concepts? The first one is called encapsulation. Encapsulation. Second one is inheritance. Third one is polymorphism. And fourth one is abstraction. These 4 are called the concepts of OOPS, object oriented programming structure. When you're writing a program based on this, these 4 are the concepts that are mostly implemented directly into writing programs like this. So what are these concepts? We are going to discuss it now. First of all, I'm starting the video with first concept called encapsulation. The next video I'll explain more about the next concepts. Okay, so let's see encapsulation. What is encapsulation? Encapsulation basically means securing the data within a class. So example like this, we have a class called A, or let's say a class called player. Okay, the class player has some data like int health and damage and defense. Okay, now when I want to access this data, I can directly access it just by using an object. For example, in the main function of the another class, we have a main function somewhere, and in that main function I'll say player p equal to new player. So immediately what I'm going to do is I'm going to give the player dot health equal to 100. So directly I can access the code like this. Why? Because this is what the class basically means. Class is a object structure. Class holds the structure of the object. What is the object here? Player. The player has this data, so the player object can use the data. That is why it is able to access it. But if I use the program like this, what happens is sometimes there are people who like to mod the programming. For example, in case of Minecraft, you can create mods for Minecraft. You can create your own worlds, you can create your own restrictions, your own assets in Minecraft. So in Minecraft, if you want to create a mod, you can easily access some things, but you cannot access everything. You know why? Because of encapsulation called private. So if you want to change the health of a player, you cannot do it with a mod. You cannot do it with a separate program. You have to do through the actual class functions. So let me explain that first. First of all, what is a private or what is a public? We'll see that later. First of all, we'll see what happens here. So as we saw, if I say p.health equal to 100, it is easily accessible. Let me show it in the real world. In the concept of programming, this is where it is. Let's make a new class. Let's make a new class, a new package pck2 pack2. Okay, let's say encap demo. Here I'm going to create a class outside this called as class player. In this I'm going to create two variables, int health and string name. Okay, now I want to access these variables here. So in the main function I simply just write player here, p capital, sorry, player p equal to new player. Now if I say p dot health, health, I can access it. If I say p dot name, I can access it. What is the problem in this? Well, the problem in this is, as I explained, when you are creating mods, or if you are trying to use any third-party mods for your games, let's say the mod can able to access the data. Let's say that mod is able to access this health data. They simply change the health data to infinity. Now the mod will make you infinite, like you cannot able to die in a game. Well, it is good, but sometimes just think of like the people who are using cheat codes. Like in MMORPGs, when you see a person cheating in the game, is it good or is it bad? If you are cheating, it is good. If someone else is cheating, it is bad, right? So to avoid these situations, we need to restrict the data. How do we restrict the data? Well, there are three different keywords for this. To restrict the data from accessing outside the class or unauthorizedly accessing the class variables, we can restrict the data by using three different keywords. Encapsulation is this. Encapsulation basically means restricting the data of a class. So to restricting the data inside a class is called encapsulation. Well, to restrict this, to handle these restrictions, we have three keywords. Number one is public. Public is a global access specifier. You can access the variables and functions from anywhere if you declare them as public. Second one is private. This is a local access specifier. Basically means you cannot access it from outside the class. You must access it only within the class. So if I declare something private, for example, here I said in the bus class, I said private. So what happens here is this seats, vacancies and num stops are only accessible within this class. Within this class. These are not accessible outside the class. Then how can I access them outside the class? Well, to do that, we have getters and setters. We have get, and we can also create a set like this. Public void set values. Okay, and here you give the parameters. And then you set the values within the function. So this is how we use getters and setters to access private variables. Understand? Sometimes you also need to block the logic. For example, some functions that hold the logic need to be blocked. So in that case, we also declare private void function one, something like this, and then we call this function directly within another function, like constructors. So as soon as the constructor starts, the function one calls. This is how we use them. So sometimes you need to restrict the access of the variables as well as the functions. In that case, we use private. So private is a local access specifier. Public is a global access specifier. Anything declared as public, for example here, can be accessed anywhere. Within the class, outside the class, within the package, outside the package. What do I mean? So in this case, I am using a package here, like OOPS. For example, I want to access this bus class into Encap demo. I simply have to do like this. Just say bus B equal to new bus. And you can see automatically it is directly accessing from the OOPS concept. See, bus OOPS, right? So if I create this, it is by defaultly imported from the bus class, right? So it is easy to access. It is directly accessible from the bus class. Now, if I want to access the code, for example, say b dot get number of seats, stops, vacancies. What are these? These are public functions here. Public, public, public. Understand? So these are public functions. Public functions, so we can access them. But let's say I want to set the data. Set the data like this. b dot set values. There. We have the set value. Right? So if you go here, we can see set values. This one. Right? So we can able to access the data from the class using public, and in the class the data that is to be restricted is given as private. Understand? So this is public and private. But I said there are 3 keywords. What is the third one? Well, the third one is very special. It is called protected keyword. This is you can say it is most useful in inheritance. When you are using inheritance, I'll explain about this keyword again, but just to give you an understanding, in protected keyword, it is only able to access within the child classes. Okay, child class access. So I'll explain about this keyword again when I go to the inheritance concept, which is the next video. So for now, we'll deal with this encapsulation. So public, private, and protected. Public, global, private, local, protected, child class access. That means inheritance access. This is called encapsulation. Understood? So encapsulation is mostly used to restrict the data inside a class. Why are we using this? So that we can able to use the OOPS concepts. This is an integral part of the OOPS concepts. When you are creating applications using OOPS, you have to follow these 4 concepts, 4 structures: encapsulation, inheritance, polymorphism, and abstraction. So every programming structure, every programming language that is using OOPS concepts like Java, Python, C++, C#, Dart, Kotlin, JavaScript, so and so. So there are so many programming languages. Even new programming languages also are using this structure. Every programming language has these 4 concepts: encapsulation, inheritance, polymorphism, abstraction, because this is the OOPS concepts. Class and object is what we are writing the program in. The programming that we are writing is about objects in the class. So those 2 are also part of the OOPS concepts, but the actual OOPS concepts are these 4. Okay. Now, encapsulation is mostly used to stop hackers and scammers from accessing your data from your application, directly from your application. They can still access it, but we are restricting them as much as possible within the application. Okay. So to if I give like this, for example, if I just say int health damage defense, it is like an open book or an open door. The front door for your apartment is open. Anyone can come in and anyone can access the things in your apartment. This is how it is. So I am just restricting the access to some things. Okay, that is called encapsulation. Encapsulation is not completely restricting the access. There are still some methods to access the values and functions, but it is creating a level of security within your application. Okay, this is encapsulation. Now, when you talk about modern programming structures, like for example, in modern programming languages, let's say in Angular or React, we have new languages like Kotlin, we have Dart. So these languages also have these structures, these 4 concepts, right? If it is not so, if it was not so influential, then those programming languages also won't be using this. So there are people who wants to rage bait you saying that OOPS concepts are overrated. Well, if it is overrated, it is not that prevalent in the market nowadays. Even every language, every framework nowadays is using this concept. So learning it is number one priority for every programmer. As a programmer myself, I am uh, like urging you to learn these concepts. Okay. Now, what about the next concept, inheritance? Well, encapsulation is all about restricting the access, right? What about inheritance? Inheritance is about accessing the data from one class to another, which I'll explain in the next video. So for now, let's say in this class where I am using this, in this class, if I want to access this data, I can simply just write public, right? So if I use public, everything will be accessing. Every application can access this data. What if I use private? I cannot access the data outside. Let's say I set private and I want to access this p.health. Since p.health is a not accessible here. For example, say p.health equal to 100 or 10. So you can see health is not visible. Why is it not visible? Because it is set as private. If I click here, change visibility, it will be set to not private, not private. So sometimes people, some programmers might get like confused here. What is this type? This is a very interesting one. This is called a hidden type. It is called a default type. This is a fourth type of access. Default. So basically, anything that is not public or private or protected is a default type. It is a hidden type. This basically means class. It belongs to the class. So anything can access the class, then you can access the data. If you can access the class, you can access the data. That's how it is. Okay. Default, you can remember this as a package specifier. Package access specifier. So within the package, if you want to access the data within the package, you can access it. For example, I go here and I create a class here, like a bus is there already. Let's create a class. Let's say demo1. The class is demo1. Okay. Here I want to access the bus. So I say bus be equal to new bus. So I can access the bus directly. But what if I want to access, let's say, a normal variable int num? Okay. What if I want to access a? So what if I want to create an application where I want to access this number? Let's say I want to access this number. So in this demo1, which is in the same package, you can see here OOPS and OOPS. Okay, it is in the same package. Now, since I am in the same package, I'm going to like restructure this. Okay, Control Shift. Okay, nice. So now we have a class that is having a simple default variable, default access variable. This one. This variable has no access specifier. If you see here, I'm not saying public or private. I'm just giving as int num. Now, if I go to demo1, I can simply access it like this. B dot. Oh, sorry. I need to create a function for this. Public demo1. B dot num. You can see I can directly access the num variable int num into my program equal to 90. Okay, I can directly access the num here because it is default. What if I say private? Immediately you will see a change. I didn't change the program here. Immediately there is an error here. It is saying not visible. Okay, I'll just go back to bus and I remove this private and immediately it becomes accessible again. This is called default access specifier. Default access basically means you can access the variable or the function within the package. What if I want to access this outside the package? Let's try. Let's go to Encap demo, which is outside the package. It's in a separate package. Now here, if I say bus b equal to new bus, bus b equal to new bus 000 b dot num. Where is num? Not possible. Let's say 89. Num is not visible here. You can see num is not visible. Change visibility to public. Why? Because it is default specifier. It's a hidden specifier. It is a hidden specifier given in the classes. Sorry. Now when I say public int num, immediately you will see num is accessible. It is coming from bus. When I create this, when I remove this public, immediately this num is again not visible, but it is able to access in demo1, which is in the same package. So demo1 is in the same package, so it is accessing it, but encap demo is not in the same package. It is in a separate package, so it is not able to access it. This is default. Understand? So anything created with default can be only accessible within the package. This is how you should understand this, because the classes are able to accessible within the package. Okay, anything which is public can be accessed anywhere within the class, within the package, or outside the package, anywhere. Anything which is private, only within the class. Protected is a inheritance concept. I'll explain in inheritance. Default access is a package access, package specific access. Whichever package you're writing in, the programs are able to access the data within the package. The same thing with functions as well. If I write a function here like void fn1, the same thing will happen with the function as well. If I go to demo1, I can access it, b.fn1 here. But if I go to encap demo, I can't access it. If I just click here, b.fn1, it says cannot visible. See, not visible. Change it to public. So why should I change to public? Because then it is able to access outside the package. It is in a separate package, so it is able to access outside the package. Meanwhile, the class that is within the package is able to access it. Understand? This is what we call as encapsulation. Encapsulation is all about restricting the access of data within the class. It is not completely restricting, but it is somewhat reassuring to the player, to the programmer, that the data that you are storing in the class, or the data that the variables are holding, are not able to access outside the class. Okay, I hope you understand this concept. The next concept is all about inheritance. We'll talk about inheritance in the next video. Thank you. Bye.